Stone tools are the primary finds in prehistoric archaeological excavations. They enable us to reconstruct many aspects of ancient human life and behavior. The earliest known stone tools date from 2.5 million years ago. This film shows the manufacture of a variety of Paleolithic and Neolithic stone tools in an attempt to reconstruct the technology and methods used during 1 million years of toolmaking. The film follows a timeline, opening windows onto some stages of the evolution of stone technology as it is understood by archaeologists today. From early times, humans have produced sophisticated tools requiring a high level of dexterity, planning, and imagination. These tools are from Gesher Bnot Yaakov on the banks of the Jordan River in Israel.
It's said in the model.
Producing a finished tool from a piece of flint involves many stages and demands planning and technical knowledge.
Excellent cutting edge.
Early humans looked at a rock, saw the tool's image implanted within it, removed the waste, and brought the tool to life.
When we look at this map, actually, it's
Archaeologists return from the field with the finds and detailed documentation of their discovery.
sort of concentrations around this.
All of the stone tools are measured and recorded, and questions begin to emerge. Where did the prehistoric knappers obtain their raw material? And how did they extract it?
Which would give less surface.
How were the stone tools made? Which working tools were used to produce them? How much time and energy were invested in each specific tool? What can we learn from the patterns of tools and waste excavated at an archaeological site about the types of activities that took place in it? The archaeological finds alone cannot answer these questions. Experimental archaeology, in our case flint knapping, has been developed to help answer these questions. Har Keren, located in the northwest Negev of Israel. Its Eocene flint beds are interspersed within layers of limestone. They were formed on the floor of the huge Tethys Sea around 45 million years ago. Flint occurs here in the form of very large nodules. For tens of thousands of years, humans came here to look for flint and quarry it for tool production.
So I clean this for the surface material.
Once flint of high quality is located, quarrying begins. The process, using antler sticks, stone picks, and hammers, takes considerable time and energy. The nodule of flint is extracted, and the detaching of large flakes begins. Giant cores are knapped to reduce the massive nodule to pieces of transportable size. The knapping of giant cores and the production of large flakes require a great deal of dexterity and experience. Here, the knapper is using a basalt hammer weighing about 1 kilogram. large flakes are removed sequentially. The scar of the previously removed flake becomes the striking platform for the removal of the next one. The flake morphology is dictated by the use of a hard hammer, as well as the great force applied by each blow. The flakes are characterized by large, plain striking platforms and prominent bulbs of percussion. In a short time, a napper can turn a nodule weighing 30 kilograms into dozens of flakes, suitable for use as blanks for tools and smaller cores. The flakes are sorted by their morphological suitability for the types of tools into which they will be shaped. The selected flakes are now transported to the base camp, where the next stage of tool manufacture will take place. At the base camp, the napper assembles the large flakes that will be used as blanks for the production of the bifaces that are typical of the Lower Paleolithic. Here he is napping a cleaver, a tool that is typically made on a large flake. The napper is using a large antler billet, made of a material that is both strong and durable and soft and elastic. He systematically works on one face of the tool, removing a series of flakes. Next, the other side of the tool is worked, using the same technique. The tool's working edge is scraped and abraded to enlarge the surface and create a suitable striking platform for the removal of large, thin flakes. The production of a cleaver takes only a few minutes. Cleavers were most probably used for cutting meat and other tasks of this kind.
Very sharp tool now.
A similar technique is used for the napping of a basalt cleaver from a large basalt flake. Basalt is a much more difficult material to nap because it is less homogeneous, making it harder to control the flaking.
It's a little bit heavy.
In addition to cleavers, the Acheulean culture is characterized by hand axes, typically shaped like a teardrop. Some hand axes are very thin, and their standard of workmanship is astonishingly high. Accurate preparation of the striking platform is essential. The removal of each flake is carefully planned in advance to further the objective of thinning the tool. Traces of the removed cutting edge are visible on the striking platform of the flake. As time passed, bifacial tools lost their primacy among stone tools. Core tools gave way to flakes detached from cores and retouched into flake tools.
Very rough grain flint.
The main technique used during the Middle Paleolithic for the production of these flakes was the Levallois technique. The napper shapes the core in a series of steps, each carefully planned.
Some kind of sandstone.
The first step is to remove a primary flake from a cobble in order to create a primary striking platform. In the second step, the napper isolates the striking platform for the next flake. This ensures that the blow strikes exactly the right
This is a
point
trade
to
secret.
detach the flake that is planned. This is how the typical multifaceted Levallois striking platforms are created. The process of preparing the striking platform and removing the next flake is repeated again and again.
So it's gradually building.
The core loses volume and acquires the shape that is typical of Levallois cores found in archaeological sites of the Middle Paleolithic period.
This is one of these predetermined. And this was
Application of the same technique to longer cores results in flakes of correspondingly longer proportions.
A blade, very regular one. And it has exactly this.
This is how one of the most typical Levallois
This
products,
is the point,
the Levallois point, is produced.
and it's a classic product, true blade.
In the Upper Paleolithic, beginning some 40,000 years ago, tool users and makers turned to longer tools.
Better blades be improved.
The manufacture of blades from a blade core is similar in principle to the production of Levallois flakes.
See? Some
The invention of the punch technique was a giant step forward for lithic technology.
rounded.
This indirect percussion technique gives the napper maximum control over the point of percussion and the force applied.
Not very much force. I have to be careful not to break the blades.
The punch can be used in the preparation of striking platforms. The position and stabilization of the core are crucial for successful blade production. For the production of very long blades, in the range of 30 centimeters and longer, careful preparation is essential. The napper invests all of his knowledge and experience in the preparation of the napping tools, as well as the core and particularly its striking platforms. It sometimes takes more than 2 hours until the first blade is removed.
It's shattered a little bit. The support.
The characteristic waste that results from removal of the core's ridge is known as a ridge blade.
Flake.
These are often found in sites where blades were napped.
Type beginning.
Punches were also used in the European Neolithic for the production of square-sectioned tools. The punch technique enabled the napper to make square axes that were polished into ceremonial axes.
Calcolitic.
From the blades produced, the napper chooses the ones that are suitable for shaping into tools by a process called secondary modification or retouch. When making an arrowhead, the napper chooses a blade of appropriate shape. He retouches the blade's edge until the end breaks off spontaneously.
See, I'm making a
The sharp edge that is created is suitable for an arrow tip.
Where they produce these points and stuff.
The broken end is characteristic waste of this process.
Like a chisel edge.
The tang is then shaped by retouching with a small stone hammer. Using this technique, the production of an arrowhead takes only a few minutes.
By making a notch.
One of the most common tools of the Upper Paleolithic is the burin. First, the napper truncates the blade using a stone hammer and a wooden anvil. Then he prepares a striking platform on the truncation surface.
Now I strike it on the hammer stone, see?
Finally, the blade is struck against the hammer.
Not. There. Plum. See, it
The
makes
scar
this-
formed on the blade is the
for sure,
burin.
that's it. This is now 90 degree and it's up.
The burin is particularly suitable for tasks such as woodworking and antler shaping.
I want this line to be
The sickle
completely
blade was
straight.
developed when plant
I
harvesting
can have
became the predominant form of
sickle.
subsistence. First, the napper retouches the back of the blade. A flint flake is used to create the saw-like edge of the sickle. Sickle blades, like arrowheads, were fixed into a shaft.
Okay, these here
In
are
proto-historic
different products
periods,
which are
such as
much
the
more
pre-dynastic in
refined
Egypt,
flaking.
bifacial napping reappears, this time of the highest technical quality.
Chalcolithic, even some early Bronze Age.
The nappers of
Made
this
different
period
types of
produced what we know as
This
leaf
kind of
points.
brownish, reddish, black, bluish, and this reddish one.
The thinning of a
this
leaf
is
point
silicified.
follows the same principles as hand axe thinning. The napper is using a very large antler billet, as high energy and speed are crucial. Stabilization of the tool is essential for a successful blow. The flakes produced, known to nappers as diving flakes, are long and thin and are often broken because of the high energy invested in the blow.
And the bodies here.
Leaves were sometimes used as blanks for the production of very fine tools using a pressure flaking technique. This technique enables perfect control of the removal of small flakes.
Smooth surface. And
The
then
working tool
do the
is a
zero
handheld
deep
antler flaker.
the ridges in between. This tool,
One of the first
increase
metal tools
the
used by
force
humans
pressure
was
point.
probably the copper pressure flaker. The copper tip is placed inside a wooden shaft to increase leverage. The serial removal of flakes by this technique can result in the production of very thin and sophisticated tools. A number of different working tools were used in flint napping. These tools can be identified among the artifacts found at archaeological sites.
This is a
The large,
soft
hard
hammer
stone hammer is
chalk
probably one of the first tools used by
uh,
prehistoric nappers.
repeatedly in both ends.
It is used for the production of large flakes.
Soft-mode flakes. It's also,
It can also be used as a mallet for indirect percussion napping.
and it was the
The medium-sized stone hammer is used for the removal of flakes in the Levallois technique and for other direct percussion napping techniques.
and it had
Small stone hammers are used for a variety of tasks, such as abrading and scraping of the striking platform. They are also used for small-scale secondary retouch and for the maintenance of knapping tools. Archaeologists hypothesize that prehistoric knappers used wooden hammers. They are normally used by modern knappers as mallets for indirect percussion, but a hardwood, like this piece of boxwood, can be used for direct knapping. The antler billet represents a revolution in the history of lithic technology, as there is no other material in nature that has its unique combination of strength and durability together with softness and elasticity. It is also readily available.
This is a heavy,
The antler
massive
punch is used in the
made by
indirect
loose
percussion
alpes
knapping
alpes.
technique.
And this is a
The
smaller
invention of the
one.
punch
These are exactly
paved the way for the
shapes and
dominance
sizes
of
we
blades
find
in the human tool collection.
many Scandinavian, many Danish sites, rock sites.
Experimental archaeology and the controlled knapping of flint tools help us to answer many questions. We have seen where raw material is found, how it is quarried, and some tools and techniques used by knappers. The ability to recognize typical waste products enables the archaeologist to reconstruct the knapping technique used at a particular site. Understanding the principles of flint knapping and the sequence of the production process allows reconstruction of different knapping activities and even enables identification of different work areas. The study of lithic technology attempts to reconstruct the life of prehistoric humans through the collection and analysis of artifacts. Experimental knapping makes it possible to identify and understand the thousands of pieces of flint tools unearthed in prehistoric excavations. It opens a window through which we can get a glimpse of the behavior, thought processes, and mental abilities of prehistoric people.